Hi class, today we're going to solve radical equations. A radical equation is going to look like this, where you have some kind of radical within the equation. The first thing that you're going to want to do when you solve these is you're going to want to isolate the radical, just like you would want to isolate a variable when solving an equation. Notice this one has a 3 in front of it being multiplied by it, so that's going to have to somehow get moved. We also have a minus 5 here on the end, and that will have to be moved somehow. And when you're solving a regular equation, you always start by moving whatever is being added or subtracted. So we're actually going to start right here with this minus 5. And since it's a minus 5, the opposite of subtracting 5 is adding 5. So we're going to go ahead and add 5 to both sides. That's going to make this go away, so we're left with 3 square root of x plus 5 equals 15. Now that we've moved what's being added or subtracted, we need to take care of the 3, which is being multiplied by it, just like that would be the next thing that you would do if this was a normal equation and this radical was something like y instead of the radical. And the 3 is being multiplied by the radical. The opposite of that is to divide. So we're going to go ahead and divide both sides by 3. When we divide both sides by 3, the 3's end up canceling, which leaves us with the radical all by itself. Over here, 15 divided by 3 is 5. Now that the radical is by itself, what we need to do is somehow get rid of that square root. And the opposite of square rooting something is to square something. So what we do is we raise both sides to whatever power would make the radical go away. So if this had been a cube root, we would cube both sides. If it was a 4th root, we would raise both sides to the 4th power. If it was a 5th root, we'd raise both sides to the 5th power, and so on. Since this is a square root, the opposite of square rooting is squaring. So we will square both sides. When we do that, since the square and the square root are opposite operations, they cancel each other out, and you're just left with x plus 5. On the other side, 5 squared turns into 25. Now we have a regular equation. So once you've gotten rid of your radical, you go ahead and solve the equation the same way you would normally do. So in this case, we're going to subtract 5 from both sides, and 25 minus 5 ends up giving us 20. So 20 would be what we would believe is the solution. However, sometimes when you are dealing with these radicals, you'll do everything correctly, and when you get to the end, you'll end up with what's called an extraneous solution. So when you plug it back in to check, it actually doesn't work. So you want to make sure that you always check your solutions on these. So we're going to check our solution of x equals 20 by going ahead and going back to this original equation and plugging in 20 where we see our x, and our x is right there. So what that's going to give us for our check is 3 times the square root of the x is going to be replaced by 20, and then we have our plus 5 minus 5 equals 10. So now we just follow order of operations, and the first thing we'll do is the 20 plus 5, which is 25. And then we have to take care of the square root, and the square root of 25 is 5. And remember, there's an implied multiply right here between the 3 and the square root of 25. So this becomes 3 times 5 minus 5 equals 10. And 3 times 5 is 15. And when you subtract 5 from that, you do get 10, so this one does check out. So we would say the solution set is, and then in set brackets we put our 20. And that would be how we solve this. So the first thing that you want to do when you're solving these equations is get your square root by itself, Then you want to square both sides, or if it's a cube root, you'd cube both sides and so on. Then you just solve your equation normally. Now let's take a look at one more of these. This one here is going to be slightly different than what we just saw. So what we're going to have here is something where you actually have a radical on both sides of the equation. So for instance, we might have 5y minus 1 underneath our radical equaling the square root of y plus 1. Notice that there's two square roots, but both square roots are actually by themselves already. So we can actually go straight into squaring both sides in order to make the radicals go away. So if we square both sides, the square and the square root cancel here to leave us with 5y minus 1. And they also cancel over on this side to leave us with y plus 1. Now we have just a regular equation where we can go ahead and solve. So we're going to start by getting our y's on one side, and that's going to happen by subtracting y from both sides. That leaves us with 4y minus 1 equals 1. And now we need to move the minus 1 here, and the opposite of subtracting 1 is adding 1. So we're going to add 1 to both sides. Those cancel, and we get 4y equals 2. And then finally divide both sides by our 4 and reduce our answer, so y ends up being 1/2. Now, just like the last one, you do want to make sure you check this to make sure that it works. So we're going to go ahead and plug it into our original equation, which is right up here. So to check this, we're actually going to plug the 1/2 in for y right here and right here. And that's going to give us the square root of 5 times 1/2 minus 1 equaling the square root of 1/2 plus 1. Now, on the right-hand side, that's going to be the easier one because 1 is the same thing as 2 over 2, which would give us common denominators. So this becomes square root of, if we add our numerators, 3 over 2. What we hope is that on the other side we get the square root of 3 over 2 also. So when we multiply the 5 by 1/2, you can remember that the 5 is over 1, so you multiply straight across. And this becomes the square root of 5 over 2. And if we want common denominators, this 1 here will become 2 over 2. And now you can subtract your numerators, and 5 minus 2 gives us 3/2. And again, it checks out. So we would say that the solution set is 1/2. Now, if we had checked this hypothetically, and instead of getting square root of 3/2 equals square root of 3/2, let's say that we had gotten square root of negative 3/2. We didn't, but what if we did get square root of negative 3/2 equals square root of negative 3/2? They are equal, but when you're checking these, a negative underneath the radical is not okay. So if you get something like this, where you have negatives under the radical when you're checking, then you would say that it is an extraneous solution, and instead of having the solution set as 1/2, we would say that there is no solution. In this case, we didn't get the negative underneath, so it did check out just fine. But if we had, we would not accept that as a solution. So keep that in mind, that you don't want the negatives under the radical when you're checking. Let's take a look at one more of these. This next one's going to have